Well, hello friends. Today we are gonna implement the mprotect syscall, and it looks like this. Just gonna look at the Linux man pages because that's what I normally do. And it's about changing the protection flags for something that you've mmapped, basically. So what we're going to do is we're just going to allow you to mmap something and then change your mind about what the protection should be. We're not going to do region splitting, merging, stuff like that, but we're just going to allow you to change like an existing mmap's protection. And I think the easiest way to test this is to make a little crash for it. So I think we'll add a flag here. Write to non-writable memory or read-only memory, because we have this little crash program, which is really great. It's a bin crash, and you can use it to crash yourself in various ways. So we'll add a new one called -r, which will be to write to read-only memory. I love this program. It's it's really neat. Okay, now we're gonna need to have this is a man. And I always forget what the hell is, like, there's so many arguments to mmap. I never remember all of them. So I guess we'll say footer map anywhere. Give me one page. I want prot read, prot write, and guess I want map anon, no FD, no offset. Okay, and so far so good. And then if this works, then we'll say footer is, or let's do this, U8. This should work, right? Like, this should work fine. And then we should do, so what was the thing here? Dum, dum, dum. So we would do mprotect footer and the size of it, and then we'll say just prot read. And then we can say like assert footer is x. I feel like the compiler might like optimize this away, so let's do what's the thing that we do? Asm volatile memory. I think you can do that. That looks so horrendous. Why do you have to look so shit? Stupid. Okay, well, fine, look that way then. Okay, I hate this about Clang format, but I don't think I can do much about it. So basically what this does is that it tells the compiler, hey, I'm doing something here, you don't know what it is, but invalidate all your assumptions about memory. And that will cause it to not optimize away this check here. I mean, I could make a helper for this. I have a helper for this somewhere in the kernel, but I don't have one in user space. Anyways, it doesn't matter right now. What matters is, or actually, why do I even do this? Like, surely calling this thing is enough. It's not going to think that this thing is the same after I've called a function. Okay, I don't know what I was thinking. Yeah, I don't need any memory barrier for this. I'm just being stupid. Okay. And then we should try to write to it, and this should crash. Okay, so now let's go and implement mprotect. So first thing we'll do is add it to the list of syscalls. Wow, it's been a while since I was adding a syscall. No, not syscall, mprotect. Syscall cpp. Mprotect, and we'll call current process sysmprotect arch1, size t arch2, and int arch3. Perfect. And then we have to go and actually add this here. So let's see, adding it to the process class so that we have something to call. Yeah, I don't really need to specify what these things are because it's kind of obvious that, I mean, okay, fine, it's not super obvious. We'll just say prot here. But these two are obvious. Sometimes people ask me, like, why do you leave out parameter names in some cases, and in some cases you don't? I leave it out when it's obvious, like dead obvious from context or from type name, what the thing is. So for instance here, sysstat. It is obvious to anyone who's been doing Unix programming that this is the stat path and this is a stat buffer. I mean, these are kind of boring. Like here is much less obvious, right? Like mount, you definitely need to specify because you have two const char pointers. So like which is which, I would get tripped up by this for sure. rmdir, this one is probably less necessary. I probably wouldn't write it out if I was doing the code right now. Anyways, that's what that's about. So I just try to like omit them if it's obvious what it is. It's just a style that I picked up in the WebKit project that I always liked. Anyways, oh, oops, that's not where we were going. Okay, so then let's look at sysunmap maybe, because it's kind of some inspiration here. So sysmprotect, adder, size, and prot. So far so good. And then we'll also use region from range. So if we don't find this region, we'll just say e and val. Now this is like not the correct POSIX behavior. The correct behavior is to allow subregions, and if you hit a subregion inside of a bigger region, then you should like split the bigger region into two new regions and then create a third region for the one with different protection, and then like splitting and merging. But we're not going to implement that right now. We're just going to do full regions only today. So let's see. What do we want to look at here? So I guess now we have a region, and we can call set writable. I guess prot and oh wait, hold on. If prot and prot write, because writable is really the only attribute that we have any control over on x86, which is the only platform that we support right now. So like in the future, this should be extended to support like no execute bits and stuff like that. But really, like right now, writable is the only thing that we control. Although I suppose if it's not readable, then we just shouldn't map it. But if something is not readable but writable, I don't know what to do. I think we can't do that. I'm not sure. I mean, I suppose we could. I don't know, like if you could do that with some page fault trick. I haven't thought about this. Anyways, I'm getting sidetracked here, so let's get back to it. If prot right, or let's just do it this way. Set writable prot and prot right. Okay, and then what is the thing that we call a remap region? Page directory and region. I think maybe that's all that we have to do here. Yeah, it's basically the thing that we support, I think. Let me check some other code. Rewrite exec, but like we're just pretending here because we don't do anything smart with these. There are some tricks that we could do. I've been thinking a bit about that lately, but I think that I'm kind of hesitant to start doing clever tricks on x86 if we want to port over to 64-bit eventually anyway. I'm not sure we should be getting too clever and like introducing more like x86 specific stuff. But I don't know, maybe it's not a big deal, but don't know. Doesn't matter right now. We don't care about that right now. We just care about prot write in mprotect. Okay, so I guess we'll just try this and see how it works. Man, mprotect. We have some errors that we forgot about checking. If you mmap a file to which you have read-only access. Oh, that's interesting. Invalid flags. Okay, well, there's a whole lot of errors that we should be handling, but we don't right now. But I'm just not going to care about those at the moment, and we are instead only going to implement this tiny slice of functionality that we want. Prot, okay, and what I'm doing now is I'm just adding the Libc wrapper for this syscall because I forgot about that. Syscall, sc mprotect, address, size, protection. Okay. So what this does here is that it just it calls the mprotect syscall with these arguments that we've been passed, and then it takes the return code, checks if it's negative, and if so, it puts the return code, like negative return code, into errno, and then returns -1. Crash CPP, an unused variable. Well, look at that. I guess we'll say that. It's almost like a little unit test. Should write some unit tests for POSIX stuff. Lately I'm thinking more and more about how it would be so nice to make like a little collection of little Unixy programs that you can just run, and it will tell you whether or not you are running on a POSIX compliant platform. Wouldn't that be a nice thing to have? Crash R. Okay, so we crashed. That's cool. I guess it was not very informative, but let's just check here. We are about to crash. Oops. I have to rebuild everything anyway. But I think that this is pretty good. So, wow, this is very straightforward today, actually. Come on here, crash-r. We about to crash. Yeah, it totally works. How awesome is that? It was so easy too. Love it. So let's do a patch review. Very quick syscall implementation. Okay, here's mprotect. What we do is we look up a region from the range that we were told, this range here. If it's not valid, then we return inval. Otherwise, we set the writable flag to the writable flag from prot, and then we remap the region. I suppose we could skip this part if nothing changed, but well, whatever. That's something that we could care about in the future if we discover that it's a problem. Here's the declaration of that, and then here's the dispatch in the syscall table. Here's the syscall being added to the big list of syscalls. Here's the Libc wrapper for mprotect. It's a prototype for that. And then here is the little crash program to test it out. Write to read-only memory. Okay, I think this is a pretty good test because we verify not just that this works, but also that the memory is writable before we change the mapping, and then still readable after, but not writable. So it's very, very good. And then I guess we can look here. We can see that it's an unrecoverable page fault with a write to this address, 102B0, which is this memory mapping right here. So everything is totally cool. Nice. Nice. Let's commit this all in one go. Kernel plus libc plus crash. Implement or add mprotect syscall. Dispatch adds the mprotect syscall to allow changing the protection flags for memory regions. We don't do any region splitting, merging right yet, so this only works on whole map regions. Put it this way, and then we'll also say added a crash flag test to verify that we crash when you attempt to write to memory to read only memory. Cool, very cool. Let's just try it one more time because it's so neat. Crash-r. Look at that shit. It just crashes. You try to write to this. And you know, we could actually say here that it's not readable in this little dump. Where is this code coming from? Dump regions. Let's add a little thing here. Say access. How many characters is that? 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Now we're doing computer science. And then here, guess we want to say, okay, and then they will be, region is readable R, otherwise space. Oh, actually we can do one more. Okay. Let's see how this looks. I hope I got the alignment right. Very important detail. But it would be nice when you get like this region dump on crash that you would see like, oh, well, it crashed trying to write here and it was not a writable region. So I feel like that would help you understand the output a little bit better. Okay, so we are crashing, writing to 102B, which is here, and you can see that it's not writable. And then my alignment is off by 1. Dang it. Okay. So, oops. We are just going to try that one more time. With everything looking right. Oh, shit. I just want to make triple sure. Very nice. Okay. So let's commit that as well. Kernel show region access bits rwx in process crash dump region lists. It's pretty helpful to be able to see the various it's for each region in a crash dump. Cool. Cool. Now we are good. So I think that's going to be it for this video. So if you made it this far into Black Rock Mountain, then I'm going to say thank you for coming by and hanging out with me while I hack on this, and for sticking around for this weird adventure that we are on here. I really appreciate all your company, and yeah, it's great. So let's just keep going and see what happens. Hope you saw something interesting, and I will see you next time.